right, guys. So jumping straight from our intro, let's go into QoS overview. A nice blank page. No, we're gonna draw some stuff, okay? So let's go over kind of the whys behind QoS at a high level overview before we start getting into the slides and bullet points. So what I'm gonna draw out for you guys is just a small network, right? So let's say we have this router here going off to this router here, and we have this little network here. Actually, let's make this a server. Let me backspace a little bit. Let's go ahead and make this a server. So a quick QoS overview. I kind of wanted to go through the flow of things with QoS, right? And actually, let me just delete this entire thing here and let me make it a little wider. So the flow of QoS. So let's say I have a user here. This user is a part of maybe a sales team, accounting team, really doesn't matter. If we take a step back and look at our job as network engineers, what is it? What's our main purpose? It's to enable the business to create or to implement technology standards and really anything that helps our business. We are there to enable the business to make money. Our role in that is to make sure that the network is always available, that availability is our top priority, and that user experience is not affected from network issues or network downtime. So we have this user here. Let's say this is Bob. He's connected off to a switch. That's connected to a router. This router has a WAN connection to, let's say, our hub router over here. So he's sitting off at a spoke, maybe one of our small offices. This is our HQ. And he has to talk to his managers that sit here at HQ. So one of the applications that Bob likes to use a lot maybe is Microsoft Teams. Microsoft Teams as an application, and I promised that I would get better at writing, so let me clean some of this up. So as I clean this up, Microsoft Teams is one of those applications that does a lot for us. It's kind of like a collaboration application. I know this is a Cisco course, but I know Cisco has WebEx, Jabber, and its collaboration, but let's just, Office 365 is dominant on the market and Teams is used a lot now. And with that Teams application, we have really 3 different data or package classifications within that one application. And this is going to make sense. So with QoS, at a high level overview, what we were concerned about in networks once they became fully converged IP networks, meaning that we would have video, voice, and data going across one IP link. Where in the old days, maybe you had a PTSN or dedicated voice lines, right, that didn't converge into our IP network. Usually that's not the case anymore. So what we had was data classifications where we'd say, okay, we have our regular data that users are going to use. We have our voice traffic that now is traveling over our IP networks. And then with the introduction of like video over IP as well, VTCs, now we have video. And all this traffic converges at one demarcation point, our egress link. And back in the day, sometimes technologies would move faster than WAN links could keep up. So if we had a 1.54 megabit link here, or a T1 line, it could have easily happened where we became congested on that egress interface. And now we couldn't provide that smooth, seamless experience for either our customers or our users, which is our job. So what solution did we have? We started to implement what's called quality of service technologies, where we could classify this data and choose how we want it to be sent, meaning we could set priorities, we could set queues on that actual physical interface to kind of manipulate how the traffic was sent and which traffic was given more or less of the bandwidth. So essentially QoS is traffic manipulation, and not in the security sense, not in source and destination, but in how the physical interface that's passing that traffic, how it's going to transmit and receive it at the actual link level. Meaning, okay, I have 1.54 megabits. If I don't implement QoS, what's going to happen? It's going to be first come, first serve, or first in, first out. And all this traffic is just going to, as I receive it, I'm going to send it. And I really don't have any way to prioritize, queue, or set limits, rate limits on any of that traffic. Well, with QoS, we now gain that ability. So that at this aggregation point with all this traffic, we can kind of deep dive into here and classify different data traffic. Our voice is voice, right? Our video is video traffic. Classify it and mark it in a way, and then use those markings to set queues up, and then we can shape and police how the traffic is going to get sent, giving ourselves that quality of service control so that Bob here, he can be on Teams and effortlessly send traffic. Now, why do I bring up the application Teams? Because in a converged network, this is becoming even less distinguished. And let's think about it, right? When I connect to Facebook.com, I'm doing an HTTP request. Traditionally, you would mark HTTP traffic, saying that's regular data, that's web browsing traffic. Okay? Well, then within that application, Facebook, though, that HTTP request, you may perform a video call. Can the router or can you, with just IP markings, identify that traffic? Maybe you can. So now, and I'm little spoiler alert, no, it's just going to see that as Facebook traffic still. And if you decide only to give HTTP traffic maybe 5%, now that video call they may be doing with a potential customer is horrible quality, and now you're not enabling the business properly. So all this to say that QoS is not a one size or one shoe fits all method for creating a seamless experience and a good user experience. Part of applying QoS is planning out mission critical services. And this is like at the whiteboard. So essentially you're noticing that the spoke sites that you're setting up, users are having issues. And at that spoke site, maybe geographically the ISP can only provide 200 megs up. That's the limit. They only get 200 megs up. They don't have anything more. Well, now it's up to you to plan out how you're going to implement QoS. And the reason I bring Teams into this is because of that, you're using one application to do your voice, video, and data. Or it has all three. Now you kind of get into a scenario where you're going to learn traditionally this is how we separate QoS traffic, which is still true, but possibly we need to take it a step further. And now we need to do QoS based on application, getting a little bit more content aware. And from the Cisco CLI, maybe an upgraded ISR router does have the ability to identify like Office 365. And now you can classify Office 365 traffic to be queued and policed. So just something to think about. Now, as far as CCNA exam, what I'm talking about here, okay, yeah, maybe it won't be tested, but it's important for you to understand the overview of QoS and how you come about implementing QoS policies on your network. So first thing you got to find out is what is our mission critical services? Meaning that if we do become congested, if we notice congestion is happening at this link, because if it's not happening, well, we don't need to worry about QoS, right? If we have a fiber uplink, we probably don't need to worry about QoS. But if we are experiencing congestion, you're noticing that services are not leaving the network. They're not completing their TCP flows, and users are feeling that. We need to plan out QoS. So first we got to find out is our mission critical services. And then we have to find out how we want to classify and mark that traffic and where. So this goes into the boundaries. So what do I mean by this? Well, just because I decide to mark traffic here saying, okay, anything that's Office 365, I'm going to put a marking on you saying this is Office 365 traffic. And now when you get egress, I'm putting you in a priority queue. And the reason I know how to do that is because I set up this priority queue to be like, okay, if I see the Office 365 classification or marking, I'm going to put that traffic into priority queue, and I'm going to put a shaping policy that says no matter what, it gets 1 meg of this link and goes up to 50 megs. That's what I'm going to do for Office 365 traffic. Put it in a priority queue and then shape it, give it maybe a rate limit of always getting 1 megabit per second, right? Okay, so how do we classify that? We may be able to put what's called like an IP precedence bit or a DSCP bit. Or we may just classify it based off its actual application or protocol. So maybe we match it via protocol. Well, what's in between this spoke and this HQ? It's an ISP with maybe a lot of different hops. How do we know that when it reaches here, it's going to give that the same priority? We really don't. And there's technologies that we can get around this, right? But let's say we have a tunnel that gives us the feeling of having that direct connection. Then maybe we can start talking about how this QoS matters, how because that tunnel interface, end-to-end, spoke to HQ, we do have that point-to-point connection. But this goes into our trust boundaries. So once that traffic leaves our network, is the ISP going to recognize these DSCP bits that you put? Maybe not. Maybe in the full architecture, they're like, hey, we have our own DSCP bits that we're not going to recognize yours. So this is where you kind of start getting into, well, maybe we do want a leased line connection to our HQ. Or maybe we have fiber uplink here, so it doesn't really matter. We don't need QoS. Another thing you got to plan. And the boundaries, where are you marking it at? Are you going to mark it at the switch and then configure QoS on the switch to also carry those taggings over to the router? That's something we also have to think about. Then after we figure out how to classify and mark in our different trust boundaries, how are we going to queue this? So if congestion is happening, we can't help that, right? Congestion's happening at either peak hours or it's happening. There's nothing we can do unless the ISP upgrades us to give us more bandwidth on that link. So now we got to figure out, okay, well, when we get packets and we can't send them out because we're congested, how do we want to queue them? We have different queuing methods. First in, first out is just nothing. That's just, there is really no queuing. Everything just comes in and goes as it comes into the ingress and egress, right? Then we have like fair queuing. Then we have weighted fair queuing. Then we have class-based weighted fair queuing. Then we have LLQ, low latency queuing. And then within these queues, because think about a queue, that's pretty much just putting you in a line. Imagine if we have 3 lines at the DMV, right? This is our 1, 2, 3, and 4 queues because we made 4 queue classifications. Who's the person telling us to come forward? A DMV employee, right? Well, a similar thing happens when we do this weighted fair queuing, class-based weighted fair queuing, we have someone setting a schedule saying, okay, we finally got some room on the link to send traffic. Give me some of your data. Then I'll take you. Then I'll take you. Then I'll take you. So in this weighted fair queuing and class-based weighted fair queuing, we have scheduling technologies called round robin and weighted. And then, weighted fair queuing, obviously, that's part of this acronym. But in fair queuing, we have round robin, and then we can make it weighted. And then we can do weighted fair queuing based on our classes. Then with low latency queuing, this is a priority queue, meaning if you're a part of that priority queue, so we want to put Microsoft Teams traffic in a priority queue and then put everything else into a weighted fair queue, when you see traffic in that priority queue, that leaves no matter what. That's going. It's not going to wait for a schedule. This queue is going to get emptied out before we move on to these queues. Well, where could you see the issue there then? Maybe nothing else starts to work on the network because that priority queue is constantly filling up and constantly being the priority and it's getting sent. Well, now we have to plan our shaping or our policing policies. Now we have to say, okay. We understand that we can't always give out the priority queue if all of our other traffic is going to be just not able to be gone or be able to egress. So out of our 10 megabit link, we're going to put Microsoft Teams traffic into LLQ, meaning it's always going to be gone. It's always going to be an empty queue, but we're going to rate limit it so that it still can't surpass the 3 megabits per second. So our classes 2 through 10, whatever that may be, protocol, whatever, right? Classes 2 through 10, they're going to be class-based weighted fair queuing, and then they'll get the rest of the 7 megabits per second. But now, Teams, we put it into that priority queue, and we shaped it and did some rate limiting, saying you'll always get 3 megabits, and you'll never get under, let's say, 500 kilobits. Awesome. So that's going to be QoS in a nutshell. And honestly, from there, depending on what tech WAN architecture you have, whether it's IPsec, GRE, DMVPN, then you can do adaptive QoS, which we're not going to get into here. But that's kind of the highest level of overviews I can give for QoS without getting a little too complicated. So with that being said, let's get into the PowerPoints. So QoS overview. Let's go over traffic prioritization. Kind of like we already described, part of QoS is you prioritizing traffic. Traditionally, it used to be just there was data and voice and then video traffic. And we had to prioritize which one was going to be like low, medium, or high. And this is, again, a high-level overview. You know it can be a lot more complicated than that. But applications like video and voice, users are expecting a higher quality of service with that. They're expecting seamless, because if you're using voice and video to conduct business, you're going to want a good user experience. You don't want that latency, that jitter, or that delay. So that may be higher up in our QoS priorities. And then we have some applications that can be a little bit more tolerant. Like if you're loading a web page and maybe sometimes that web page takes a little bit long to load, that sucks for the user experience, but that isn't critical to our business. And again, this all depends. So some traffic can be a little bit more tolerant while others can't. With voice and video, they can't be that tolerant to latency or delay because traffic won't arrive and then you won't be able to continue that conversation or that video teleconference call. So we have to always worry about our transmission controls like TCP. You know, with TCP connections, you know that it already does its own windowing, right? TCP scaling or windowing, where if it reaches right here and traffic is steady and it tries to do more, and then packet drops, it's going back down, right? And so with TCP, it kind of already does its own global scaling. Well, with QoS, we can manipulate that so that TCP actually performs a little bit better. But with UDP applications, like video and voice, there is no way to, within the transmission control protocol of UDP, to make sure that traffic is getting there. So QoS can be very beneficial for UDP traffic because now we can kind of set it into a higher priority. Not that we're going to get those checksums or the acknowledgements, but okay. Another thing we want to go over is congestion. You know, this is the whole reason for QoS. You don't need to implement QoS if there is no congestion on the network. So what QoS can do is prevent some of that congestion by prioritizing how traffic can be sent. And sometimes QoS may not always be being used on your network. Maybe from your peak hours of, let's say, business deals are getting done from 2 to 5. That's when you need QoS. So we configure QoS all the time, but we do it for those peak hours where we're getting congestion. And here you see like kind of what was happening a lot, you know, maybe 5 to 10 years ago before we had these broadband connections everywhere for business or these fiber uplinks. We still had these dedicated leased lines, and we had a gigabit LAN architecture that's able to send so much traffic to this router. But then on the egress, we're getting limited to a serial connection, which wasn't a lot, maybe T1 speeds. So you saw that connection at our demarcation point. And when you start to experience that, then you start thinking of QoS. If this isn't happening, congestion, it's nothing we need to worry about. Okay, then QoS traffic requirements. So with that voice traffic, there is some like standards, and I kind of was telling you there is no QoS best practice, but there is some standards on how traffic or how tolerant traffic is. So with voice, that latency has to be less than 150 milliseconds. And what do we mean by latency? So with that one-way connection, so from this VoIP phone through the ISP to this VoIP phone over here, our one-way delay needs to be less than 150 milliseconds. And our two-way, right, can be less than 300 milliseconds to have still that voice communication. But essentially, the way I like to look at it is we need under 150 milliseconds of latency no matter what. And then jitter. What jitter describes is the different latency levels between each hops. So what do we mean by that? Is if our voice traffic is traveling through these 4 routers, they need to have within 30 milliseconds of the same delay or latency for our voice traffic to be heard. And what we mean by that is if this is sending at 100 milliseconds, then all of a sudden this is 200 milliseconds, that's going to be jitter on our network. And when that happens, we need to figure out a way to maybe encode and decode that voice traffic so that it can get past that jitter requirement. And then loss, it needs to have less than 1% of loss on the actual transmission. Essentially meaning that we can't have more than 1% of packets being dropped, or we lose that voice call, or we lose the person on the other side. We won't be able to hear them if they come in all robotically. Then video. So video, if you're streaming or you're doing a video teleconferencing call, it does change a little bit. But it is similar to voice that it can only tolerate a certain amount of latency, jitter, and loss without any noticeable effects. And you see the one-way requirements here. So latency, 200 to 400 milliseconds. So you see that being a little bit more forgiving. But there's still the voice aspect in video. So you got to understand with video that it isn't always the same either. Your definition, your quality, how you're encoding and transcoding that video, this is going to all take an effect on this. If you're trying to stream a 4K video or do a video teleconferencing call via 4K, yeah, maybe the latency has to be a lot less than 200, and the jitter and the loss. So this kind of just all depends on the quality of your video. But this is kind of just like the one-way best practice that we're taught. This isn't always the case. You can stream video at a lot less latency, especially if it's like point to point. Again, we're not going to get into the complexities of that for the exam. This is what Cisco puts out as general one-way requirements for video. And then let's go over data. So depending on what kind of data traffic, maybe depends on what kind of QoS, Is the service mission critical or non-mission critical? Is it TCP? Is it UDP? This stuff comes into play when we start implementing our QoS technologies. And really, like a lot of these protocols here that are just needed, no matter what, these are kind of like our control plane protocols. Kind of, but these protocols are mission essential, meaning we need DNS, we need DHCP to be functional. Maybe we do give these a low latency queue a priority of maybe 2% of our overall bandwidth, because these don't take up a lot. DNS requests, DHCP requests are literally nothing on the link. They take almost no bandwidth, but we don't want these getting no bandwidth at all, depending on how we configure it. So sometimes it's easy to kind of group a lot of this network services traffic like DNS, DHCP, ERGRP, and OSPF routing protocol messages, right? SNMP. It's kind of easy to group all these into one class and be like, okay, this is what helps us manage and our network, or we need this routing traffic to be able to talk out to the internet. So we're going to give this a meg no matter what. All these different protocols that are needed on our enterprise, right? These are actually needs, not wants, like maybe YouTube, our users want YouTube. So we're going to, classify those a little bit different or give priority a little bit different. So again, why we need QoS, I don't want to beat this over a dead horse. We need it when there's congestion, and we need it when we need to deliver a good user experience. Okay, so we're at the 25-minute mark for this video. So I'm going to go ahead and pause it here. In our next one, we're going to go over the different QoS models. So thank you for viewing.